structured, object-oriented, dynamically typed, and imperative. Some of you may know what these words mean. We know at least one of them, or hopefully two of them mean. Let's start with object-oriented. Object-oriented means what? What do we get with Python if it's object-oriented? So we get built-in functionality for all of the OOP fundamentals. How Lua, as an example, was not object-oriented. It did not have the built-in functionality for object-oriented programming. We were able to force Lua to become object-oriented programming with some clever coding, but Lua itself is not object-oriented programming. It's not object-oriented. So Python is object-oriented. That means that we get classes, we have member variables, we have static variables, we have all of those different things that we get access to with object-oriented programming. Inheritance, polymorphism, it's all built in by default. What does dynamically typed mean?
Make it wherever you want.
What do you mean?
You can make definitions.
You might be trying to say the right thing, but the way you said it so far is not correct.
Maybe like you could change the type of the variables, whatever you need.
So it's not that you can change the type of the variable. It's that the variables don't have types. So variables don't have types. Values have types. An example of this is Lua is also dynamically typed. So for example, in Lua, the variable didn't have a type. We didn't have to say what type the variables were. But we can have different different data types. Like for example, in Lua we had numbers. In Python we also have numbers. Python doesn't discriminate between floats and integers. Those are still just numbers. Python also has what's built into what's called big number libraries, which means that there is no physical limit to the size of the integers you can use, or the numbers, not just integers. You can make arbitrarily large integers, as many digits as you like in Python. It doesn't matter. This is not true inside of Java. As an example, if we look at Java, Java has a limited value for an integer. If you look at an integer, it could be -2 billion to +2 billion in that order. If you try to store 2 trillion inside of an integer in Java, that 2 trillion would not work. In Python, it doesn't care. You can store 40 quadrillion inside of Python. It doesn't give a shit. But it is still dynamically typed. That means the variables don't have the type, but the values do. Yes?
Does that mean that the variables all have like a certain amount of maximum size of memory for each variable?
The variables do not. So in Java, for example, in 107 and 108, we push a lot of things like how big is an integer in Java? And we talk about, and even in this class I talk about that. A Java integer is how big? How many bytes? 4 bytes, right? So Java integer has 4 bytes. In 237 you learn things like there's words, which means it's a 2-byte integer, or it's a byte, which means it's a 1-byte integer. In Python, there is no effective limit. There is no size cap. And so if as an example in Python, if you say x equals 5, that variable probably uses 4 bytes. But you don't actually know, nor do you care, because the same thing is true. You could also say x equals 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Right? How many bytes does that take to store? I don't know, a lot, right? You could also do something like this in Python. Let's do that. That's a really big number, right? You could absolutely store that in Python. Python would say, sure, no problem. Let me store that for you. Yes?
How does that work at the machine level?
Internally they use something called a big integer library, and all they do is they just allocate more bytes as they need them. And they go, hey, holy shit, this would overflow if I did this addition, or if I added more zeros to this. So it adds more bytes dynamically to the size of the memory until it's able to store it.
But wouldn't that require you to be pushing things if you want things you already have in memory?
If you have very, very large things, you will run out of memory. For example, Python will probably be able to say, yeah, no problem to that number, but if you said this, Python would probably throw up. It would try, and then it would probably crash, because it would run out of memory. Does anyone know what that number is? That's a Google. What's that number? That's a Googleplex. This is where Google gets its name from. That's a Googleplex. That's really quite big. If you were able to store a single integer on each bit, you would have to have like a number of hard drives equal to the size of the planet to store it. Something stupid. It's huge. We can represent it really small, but it's a gigantic number of zeros. So that's what it means to be dynamically typed. These other two are words that you might have heard, but we haven't really talked about explicitly, and so we're going to start talking about them explicitly. Let's start with imperative. Does anyone know what imperative means?
So like something where you tell the program what to do?
Correct. So imperative means what you type is what happens. Not all languages are imperative. Python happens to be imperative. In Python, when I say x equals 10 to the 100, like so, that assigns the value of a Google to the variable x. That's what happens. We've talked about other languages like SQL as an example, where if I say select star from, let's say, some table in SQL, you don't have to know exactly what this means, but this command doesn't necessarily mean that's exactly what I'm doing. I don't know how this command is actually being implemented on the back end. And so some programming languages don't tell you how they work. And some of them, they're not necessarily imperative in the sense that I don't say like x equals whatever. There would be other ways that I would be able to declare it. When we look at Haskell, you'll kind of get your first taste of a language that is not always imperative. Haskell is still pretty much always imperative, but it's just different enough that it's not. Almost everything we do in programming is going to be imperative except for databases. Structured. This is another one. What does structured mean?
The basics.
So this is all the things that we take for granted. So for example, if, else statements, loops, anything in C with a curly brace, wrapped in curly braces. Anything in C that you wrap in a curly brace is a structure of some kind. Case, switch, cases, those are all structured paradigm parts. Does anyone have an example of a language that is not structured? Assembly. Most assembly languages are not structured. So if the 237 material that you've learned or have taken or are doing now is a non-structured language. There is no if statement. There is a compare and a branch, but there's no if statement, which is fundamentally different. Because in an if statement, as an example, the if statement in Python looks something like this. If conditional, colon, then you have, oh, that's not, what is the comment? Hashtag, thank you. Comment, so true case, and then you can have your else down here, else, your false case down here. right? That does not exist in assembly. Yes?
Do you still need the colon on the else?
I don't remember. Maybe? You remember?
I think so. I don't think so.
No? Okay, yeah, no. That's the problem when you program in a lot of languages. You start to lose syntax on specific things. And so eventually what you end up doing is you go back to a programming language and you sit there and you type it like 10 times, like, okay, that's how I do understand it. And I do when I'm in this language. One of the big things that you can get out of this class is all programming languages are fundamentally the same. They just support different subsets of concepts. Like Python is structured, that means it has an if-else statement. Assembly is not structured, that means it does not have an if-else statement, but it still has a way of doing branching. C is structured, that means it will have an if-else statement of some kind. The difference between C and Python is that C requires you to use curly braces, like so. Whereas Python requires that you use a colon for the if and no curly braces. But fundamentally, they're the same thing, they're the same language. The same concepts, not necessarily the same language. Python is some other things. Python has some pseudo-functional stuff to it, and we'll talk about what that means with list comprehensions in Python, which are probably the coolest part of Python, or one of the coolest parts of Python. Let's take a look at some class definitions in Python. Or not just class definitions. Let's look at some definitions, how we define things. Like I said on Tuesday, Python is white space sensitive, and strictly speaking, it's actually tab sensitive. So, for example, you have different layers of tabbing. If I have a definition of something, for example, I want to define a function. So to define a function, I'm going to say def. That will define a function. And then whatever the function name is going to be over here, so we'll define a function name. Let's call this monkeys. With a left parenthesis, and then I'll put the parameter in here, so the parameter will be bananas. Like so. Python uses the colon at the end of its scope beginning. Instead of having curly braces, it has the colon at the beginning of the scope. Now, since we have this colon here, after that colon, that means anything inside of this inner tab. So this outer tab line is where the definition goes into scope. The inner tab line here is everything inside this inner tab is in scope of monkeys. Right? So for example, if I say, lost some markers. If I say if let's do a for loop. For I in range 1 to bananas, we'll discuss what this range thing does here. Colon. Use a different color for that one. Like so. So everything that's in the purple and the red is inside of the green definition. Everything that's inside the red is inside the purple definition because of the tabbing. If you don't do the tabbing correctly in Python, you will not have a functioning program, period. Okay? It's a little bit frustrating in some ways, but it forces you to write or to present cleaner code at least. Let's take a look at this for loop here. For loops in Python, the way you want to think about them as being for each statements, typically, as opposed to being a regular for loop. So for example, in C, we write something like for int I equals 0, I is less than 10, I plus plus, correct? That's our standard for loop. In Python, for loops don't work that way, or most for loops don't work that way. What we want to be able to do is we want to say for I in a set of things here. So in this case here, if I wanted to do the same for loop, I would have 0, 1, 2, 3, dot, 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 all the way to 10, or 9, sorry, because I wouldn't be actually doing 10, right? And what happens is I becomes each one of these values inside of this set. In this case here, if we're looking at Python, that'd be a list of things. So I will become each one of these values, and that's fundamentally the difference between Python and other programming languages for these, in for loops. This means that you don't always, when you're doing a for loop, you're not considering the index. Typically, you're actually considering the value. You can also consider that you can use the value as the index for another array or another list or something along those lines. But typically, you're doing something inside of a list. So as opposed to saying, I want to look at every index of this array, you just say, I want to look at every value in this array. And that's the way Python works, usually. In this case here, when I say range, range is a function that builds this list for me. So let's suppose that bananas has the value of 7. If bananas is the value of 7, this would build 1, 2, 3, 4, 5, 6. And now the question is, does it build 7 or not? Actually, let's think about 1 as well. So does it build the 1 and the 7? And what would be the argument for building one way versus the other way? And then how would we figure it out? Anybody know? Anybody have a guess? Yeah.
Wasn't range you said it started at 1 and bananas were 7, it would just make sense to me 1 to 7.
1 to 7. So you're saying 1 and 7 inclusive is what you're saying. So when you're saying 1 and 7 inclusive, that okay. Why would it ever do 1 to 6 and not include 7? Does that make sense as well? That's exclusive on the far side. This is exclusive on the far side. I is less than 10, right? We're excluding the 10. I could also be exclusive on the left side. For example, if I wanted to start at 1 and not 0 over here. Let me bring this down and take a look at what it actually looks like. Of course, there's an online test of Python. Okay, there it is. Nope, not replace. Let's try this. Alright, so what I've done now is I've gone to this website that I've never used before called Replit. And theoretically what this is going to allow me to do is it's going to be allowing me to program in my browser. So let's give that a shot and see how it works. On the right hand side, it looks like I have a Python guy, Python 3.5. On the left hand side, it looks like I have some code that I can actually type. Let's go over to my Python side over here, and I'm going to say range 1, 7. Just see what happens. When I do range 1, 7, that return. What that return? Is that difficult to see? Can I look at it? Yeah. What that return? The range 1 to 7. That's what that returned. In Python, Python is a language, and this is a new kind of concept called it's a lazy language. So Python is very lazy. Python is lazy. Languages like C and C++ and Java and so on and so forth, and Lua, none of those languages are lazy. They're all active. What this means is if you write an instruction, that instruction happens. For example, but in Python this is not true. If I write a for loop in C, that for loop occurs every single time. In Python, if I say, hey, run this function, well, Python goes, yeah, no problem, bro, I'll run it while you ask me to.
Amen.
Right? And so Python is lazy. This means that Python doesn't run a command until it must run the command. It doesn't run a command until it must run the command. So when I said, hey, what is range of 1 to 7? It goes, well, it's the range from 1 to 7. Yes?
That doesn't happen on
Are you using Python 2?
oh yeah, 2.7.
Python 2 and Python 3 are different. Okay. So Python 2 is also lazy, it's just not as lazy as Python 3. Why is being lazy something that we actually like? And what she just said is actually something to support too. Python 2 and Python 3 aren't technically the same language, they're just very, very similar. So you'll be hella confused when you go through stuff, you're like, shit. You just realized, I was living in Northern California for a while. Sorry. So let's print the range of 1 to 7, see what happens then. Well, it didn't like that either. Well, let's make the for loop that does that then. For I in range 1, 7. Oh, let me. So when I hit the enter, you'll see how it automatically tabbed me in here. I'm going to do this both correct and then I'm going to do it incorrect as well. Print I 1 through 6. So did it print the 7? No, so it printed the 7 was exclusive there. Let me do this for loop here. What I'm going to do is I'm going to get rid of this tab. It won't even let me. It won't even let me do it in the interpreter over here. Let's do it on the left side over here. So we'll say for I in range 1, 7 colon print I, like so. I'm going to click run. It says error, because that print statement is trying to find I, but I should be an indented block and it doesn't exist. Or that print should be an indented block. If I do this as a print I here, so there's the indented block, I'm going to try to run it again. It'll print the 1 through 7, or 1 through 6, and then it should, I is none, I guess. It should fail. Oh, it still has I, huh? Neat. Okay. So the I still exists the same way we had in our for loop here, where the I finished at the end of it. I didn't know that happened. I thought it was this way. But it doesn't, so you're good. Those are the example between the two of them. You see it has the prints the 6 twice here. The last print there. If we have a class, let's define a function. So we'll define the function monkeys, which takes bananas, like so. And we say for I in range from 1 to bananas. Print I, or print bananas is what I said. What's this going to do? It's going to print bananas a bunch of times. How many times is it going to print bananas? Bananas minus 1 times. So if I run this, why didn't it print anything? But I didn't tell it to. But monkeys is a function, right? Well, I'm going to come over here. I should be able to run monkeys over here now, if this is working the way I believe it is. Monkeys of 5 prints 5 times because the banana is 5. Yes.
I know that in the loop, the online prints by itself. What was the decrement today? Did you got anything related?
So you want to be able to do the decrement? So let's go ahead and say Python range. So if we look at the Python range function, there's a bunch of Python has a lot of tutorial stuff. If we look at the Python range function, we can read about this. There we go. Let's take a look at these guys here. Oh, I think. You see your answer? At the bottom. So what are the parameters then? What's the first parameter here? Where to start? What's the second parameter? Where to stop? Right? And the third parameter is by how much? Right? So let's go take a look at this. Let's do this from bananas, let's say -1. Run that again, and then I'm going to say monkeys of 5. What do you think is going to happen when I say monkeys of 5 now? So you're saying it's going to go on forever. Why do you think it's going to go on forever?
Starting at 1 and going backwards until it reaches 5.
Okay.
So it's going to be negative.
So we're saying let's start at 1 and go backwards. Well, 1 from backwards is 0, and then we go backwards again, which would be -1, which would be -2, -3, -4, -5, -6, right? We ever reach +5? No. So that's the reason why we say it's going. You think it's going to be infinite. What do you think it's going to do? You're just going to say none? Did you try it already? No.
Cheater.
Why does it say none? Now you're on there. Python is smart enough to be able to figure out that it can't go from 1 to 5 negatively. It can't go that way. And so it doesn't. There is no range from 1 to 5 by -1.
It's lazy and smart. That's
It's
awesome.
lazy and smart. Right? I can't do that. But if I put -5 in there, it goes and does that. Why does it print -5 6 times? Right, because 1, 0, -1, -2, -3, -4 is 6 total. Any other questions about monkeys or functions and for loops and range and print and stuff? Yes.
Is there any way to include bananas so it actually does it like 5 or 6 times without
Let's make this positive one here. Let's make this a positive one there. Or you can start with 0, and that would also be. So that was as opposed to you wanted to include bananas, not have the total number of. Right. So they're similar but different. Right. What if I did +2 here then instead of +1? Would that +2? Would I include bananas every time? Which ones would I skip? So you're right about that. I would skip some of them. Take a second here. Don't answer yet. If I type in monkeys of 4, let me make this an I here instead, so we'll print out the numbers. If I type in monkeys of 4 here, what is it going to print? Would it print the value 4? Why does it not print the value 4? Because we're incrementing by 2. So this would be the odd numbers. Right? What if I did monkeys of 5?
1 and 3.
Because I put the +1 here, the range +1 allows the last one to be printed. If it took off that +1 there, right? That's expected. Other questions about functions and for loops and stuff? Okay, so what other things do we usually want to be able to know in Python to be able to use Python? We got for loops, we got if statements. We'll talk about classes in a little bit. What other kind of fundamental thing do you usually want to know about?
structures?
Data structures, right? Python has 2 fundamental data structures that you'll end up using. The first one is a list. Lists are like arrays. So for example, if I say A equals 1, 2, 3, 4, like so, and if I print A, it is that list 1, 2, 3, 4. Okay. I can use it like an array. If I print A of 1, what am I going to print? So you're going to say I'm print 2 here? Because 1 is the first, so that's 0, that's 1, that's 2, that's 3, right? If this was Lua, which one would I print? 1, right? So what's the question then that you need to know about the lists? Does it start at 0 or does it start at 1? What's the answer? Starts at 0, right? So that's how we can figure that out with this with the languages. So we know that their arrays or their lists start at 1. We can actually look. Python is pretty nice. It allows us to concatenate arrays really easily, or lists, sorry, very simply, just by adding them together. You don't have to worry about, it just concatenates the two lists together, which is very, very nice if you think about trying to program in C or Java or some other language. Stick two arrays together is very difficult. In Python is just one thing. Yes? What do you mean? Oh, so you want to generate 1 to 30? Okay, let's give it a shot. So do you know anything that would generate the numbers 1 through 30?
For loop.
So you could do it with a for loop, right? What was that thing that in the for loop that gave you that ability? Right, so if I said range of 1 to 30, that's 3. That doesn't give me 1 to 30 yet, right? Is there a way that you could think about doing that without writing the for loop? Huh? You could use numpy. Numpy is a numpy. I call it numpy. I don't know.
I call it numpy. I don't know about it.
I don't know. So NumPy is a numerical package manager, numerical package program that we're not going to use at all. We're not going to touch. When people talk about doing scientific computing in Python, they use things like NumPy because NumPy is very fast. They also use something called SciPy or SciPy, whatever you want to say it. What do you think happens when I do this? Would that work? Huh? Well, let's figure out what happens here first. What does that do? That work? Is that what I expected? What's the first element of that? So if I say A equals this, and I print A of 1, or A of 0, sorry, what did I get out of that? It's the range 1 to 30, right? So what can I stick inside of my lists? It's not a linked list. I stuck the range function inside of the list. I can put anything I want inside of the list. So unfortunately that didn't work. You said, what if I said A equals range 1 to 30? If I print A, it's still that range 1 to 30. Still haven't gotten that list out of it yet. That's unfortunate. Yeah.
Earlier when I did that in Python, it does make it look like an array. Is that wrong? Or is that
So in Python 2, it's just Python 2. So Python 2 is evaluating it for you. Now really this in Python 2 would look something like that. Let's see if we can bring it to REPL Python 2. Look at the difference between the two.
in our assignments? Is that
No. You won't actually have that. It is Python 2. Python? Is it Python? Let's give that a shot. What if I say range 1 to 30 here? Yeah, see this is Python 2 here? Yeah, there we go. That's exactly what we're looking for, right? So here in Python 2 we would get what we were expecting. Python 3, the answer is that range 1 to 30 is exactly what we want it to be. So if you wanted to create a list of things 1 through 30, the range function is the list of things 1 through 30. It's just not explicit. And so by trying to put the range function inside of the array, it doesn't help us because that's actually now inside of the array, inside of the actual list there. Et cetera, et cetera. Yes?
So, which allies really are more used?
For what? Oh, between 2 and 3? There is no Python 1 anymore. There's only Python 2 and Python 3. Python 2 is going to go end of life, probably in the next 15 years. So if you want to use Python 2, that's fine for the next 15 years. It just won't work. It won't exist after 10 to 15 years from now. Python 3 is what's going to supersede it. Python 3, I believe, is better. People argue both ways. I believe Python 3 is better because it is lazier than Python 2. That's just personal opinion. There's other things that Python 2 does better than Python 3. 6.5 does it better. What are we doing? Oh, There's another data type, fundamental data type in Python called dictionaries. Dictionaries in Python are almost identical to Lua tables in the sense that we create them with the curly braces like that. I can also use things that are non-standard keys for like, hello, this is a key, this is a key, equals 30. And then I can print A of this is a key. Lists do not have that functionality. Lists are really arrays that are indexed at 0. You can also have your dictionaries indexed at 0, but you don't need them. You don't need them to be indexed at 0. Python supports an interesting thing called slicing. So let's suppose we have this list of A, which is 1, 2, 3, 4, 5, 6, like so. I'm going to clear this and then redo it, and we'll see it. So Python has this list that is A, 1, 2, 3, 4, 5, 6. This concept of slicing allows you to extract some subset of those without having to worry about all of them. So for example, if I want to print the first 3 of them, oh, that's the last 3? Okay. So if I want to skip the first 3 of them, I could say 3 colon, which means skip the first 3, print the rest of them. If I want to skip the last 1, for example, I can have the colon with the 1 on the end, or that's just, I'm sorry, not the other way. That just prints the very first one. First 2. I can also do things like 2 colon 4. Those would print the ones in the center. So these are called slicing. A lot of programming languages support this, particularly for programming languages that deal with science and math. And the reason why is because you have to be able to access certain elements out of matrices and arrays when you do mathematics and simulations. This is called a Python slice. That's what they call it in Python. Very powerful concept. You can slice all kinds of things. I believe you can just slice strings straight up. Let's try it. Just slice that string. You want the skip the first 3 elements out of that string. You can slice it like so. Substrings and so on and so forth are very simple. Python deals with strings very effectively, much more effectively than Lua or C or Java or C++. Not quite as effectively, perhaps, as Bash does, in the sense that Bash gives you the ability to do grep, which is simpler to use than Python's regular expressions. But Python also has regular expressions. Typically, when people talk about scripting their computers, instead of using Bash, they'll use something like Python. The reason why they use something like Python is because Python is more platform independent than Bash. Python runs on Windows, it runs on Macs, it runs on Linux, it runs on Unix, it runs on all of them. Bash just recently started to run on Windows, and it's still not completely functional. Any other questions about these guys, or about dictionaries, or about lists for now? Okay. The next thing we're going to talk about then are classes. Classes in Python, like we talked about on Tuesday, start with something along the lines of this: class test. Let's do foo and bar instead of test. Let's say foo. I'm going to put this in here: bananas equals 3. And then we'll have def underscore underscore init underscore underscore self comma x self dot x equals x. We're defining the class foo. When we define that class foo, that bananas thing is part of the class foo. In Java and C++, when you define the class, you define the member variables that exist inside of that class. That is not true in Python. When I define bananas here, bananas is not a member of every object. It is only a member of the foo class. I have, however, defined a member variable in this code so far. What is the name of the member variable I defined? X. Let me change that X so that people who are going, you have two X's there, or three X's, which one are you talking about? This one. So now I've changed that X to be in the new member variable, this one. So the member variable, this one, is assigned the value of the parameter X. Typically in Python, you want to define your init function or your constructor or all of your constructors at the top. You want to have some base constructor that defines all of your member variables, because if you don't, it's difficult to keep track of what your classes or your objects have inside of them. It's easy enough in Python to say, hey, this object has a bananas member variable. No, it doesn't. This class foo has a thing called bananas, not the object itself. For example, if I now say the variable a equals foo of 3, let me go and run that. Let me clear this and run that. If I print a, is that foo object at that memory location. We're using a 64-bit machine. If I print a dot this one, what value is that?
3.
3, as expected. If I print a dot banana, bananas, what value should I get?
Gosh.
Well, they're both 3, huh? Let's change those things. Let's make it a little bit more explicit.
I knew I was right.
Let me do that again. Print a dot, what was it? A dot x, right? A dot this one, sorry. 7. Now I can print a dot bananas, and I get 3. Does a actually have the bananas?
No.
So the claim that we're going to make is no. To demonstrate this, how could we prove that the object a doesn't actually have the bananas?
You just make several objects.
Okay. B equals foo of 4, right? And then let's say B dot bananas equals 10. Remember? Hopefully this doesn't affect anybody here. All right, so what I did here is I said a dot foo equals or a is foo of 7, b is foo of 4, and I said b dot bananas equals 10. If I print a dot bananas, if a has its own copy, what is a dot bananas? If a has its own copy of bananas, what is the value of a dot bananas? 3, right? If a does not have its own copy of bananas, what is the value of a dot bananas going to be? 10, because b has changed it. Oh shit. Right? What happens if we print b dot bananas?
10.
10 here. Does this prove what I said was wrong? Or does it prove something else?
Print a dot bananas in that. I'm wondering if does it run the whole thing?
Because b dot bananas is 10. Let's take this b dot bananas, and what I'm going to do here is I'm going to change this to foo dot bananas. And we're going to run that. And we're going to do the same 2 prints again. So I print a dot bananas, it's 10, and I print b dot bananas, it's 10, right? If I say b dot bananas equals 15, and I print b dot bananas, that equals 15. That makes sense to everybody, right? When I say print a dot bananas, that's still 10, right? if I say C equals foo, oh, I have to pass the value. Okay, so, C equals foo. So now C is a new object of type foo. And I say foo.bananas equals 20. And I print C.bananas.
20.
What should I get?
20.
If I print A.bananas, what should I get?
20.
And if I print B.bananas, what should I get?
20. Oh shit.
What's happening? What's going on? The fuck? Yes. So let me take this up for a second. We're gonna mute this. We're gonna draw some pictures because this doesn't make sense without pictures. When I define foo, the class, I get a little box. This box is foo. Inside of foo, it has the bananas thing. Bananas. The original value of bananas was
3.
what was that?
3.
3, right? I also have a function which is called init. That is the function that initializes or is the constructor for bananas. When I create A has a member variable. What is that member variable?
This one.
This one. What is the value? Let's this one. Let's say that I said A equals foo, because I don't remember what we actually did. Foo of 7.
7.
This one will have the value of 7. Okay? A also has some additional information. What is the additional information that A has? So it's not bananas. It has some additional information though. It has information about itself. A is an object of what type? Foo. It is of type foo. What do we do if we don't find what we're looking for inside of A? We're all going to get up here pretty soon. We're all good. If we don't find it inside of A, what do? We go look inside of the class to see if it's inside of the class. When I create B, with B equals foo of 4, you get to this one here with the value of 4, also points at foo. When I say B.bananas equals 15, what am I doing? I'm putting a thing inside of B. We go look, hey, does B have bananas? No? Let's add it. These bananas is now 15. Right? So later, when I come in and I say C equals foo of 1, I get my other foo object here, C, with this one of 1, which also points back up to foo. So when I print A.bananas, I get 3. When I print B.bananas, I get 3. I'm sorry, 15, because I look inside of B, I say, hey, B, do you have bananas? It goes, yeah, 15. Don't worry about it. When I print C.bananas, we can absolutely worry about it, but don't worry about it. When we print C.bananas, we get 3, because C and A both share that bananas from foo. take a look at that one more time in practice.
Holy shit.
So we had A equals foo of 7, B equals foo of 4, C equals foo of 1. We'll say B dot bananas equals 15. We'll print A dot bananas. We'll print B dot bananas. And we'll print C dot bananas. Then we'll go in and say foo dot bananas equals 30. And we'll print the 3 of them again. And we'll run that. 3, 15, 3, 30, 15, 30. Right? So that bananas is not a part of the objects until you add it to it. Once you add that bananas key to the object, that key now overrides that bananas for that object. Yes?
When you add that variable to the object, could that have been anything?
Correct.
Okay, so it wasn't like just because there's bananas in the class, you can add it, it could have been whatever.
One second, hold on. Let me give an example of this. Does C still exist? Yeah. So I can say C dot some other thing equals whatever I want. Then I can print C dot some other thing, and that's whatever I want.
Okay. I don't know if I'm seeing this correctly, but I feel like it's just you pressing the arguments or whatever that argument is, but it turns out. Is that what's happening?
I'm sorry. What do you mean?
Actually, no, it's
I have no idea what your question is asking. Think about your question again and ask me again in a minute. It's not, it doesn't sound like it's a bad question, but one of us has a misunderstanding of what the other person's thinking.
The same way you added stuff to C and D, could you also add it directly to the class?
Correct. So if I wanted to say, for example, if I say print A dot other thing, oops, hold on, print A dot other thing, there is no other thing when I try to print A dot other thing, right? It says error, no such thing as other thing. If I say foo dot other thing equals 77, and then I say print A dot other thing, it automatically gets that 77.
Can you see if it did that for B as well?
It does it for all of them.
Even though you defined other thing?
I didn't define other thing inside of B.
For, if you did like some other thing,
Ah.
would it read
Sure, so foo dot, what was the other?
some other thing, some other thing?
I have to have the exact same variable name. There we go. So this is what I had, right? Whatever I want. Let's call this foo dot some other thing. Ooh, that's foo. Foo dot some other thing is another thing I want. If I print B dot some other thing, do you want to print C first? Some other thing is another thing I want, or oh yeah, whatever I want, because I added it to C. Because the first time I said C dot some other thing is where I added it. So that's some other thing. Now I can print B dot some other thing. And that's the another thing I want. And so I can add them in either order. This is the same way that Lua did their metatables. So when you didn't find the information in yourself, you looked in your parent. Python behaves exactly the same way. When you define a class, you're essentially defining a metatable about an object. In Java, when you're defining a class, you're defining a metatable about an object. If you can't find it in your local scope, you look inside of yourself, inside of your own object. If you can't find it inside of yourself, you look inside of your class. If you can't find it inside of the class, you look farther out. All the languages do the same exact thing. They're the same exact behavior. It's just not as easy to see. You can't do this in Java. You can't run part of a Java program and then screw with all the things that are inside the parts. Other questions? All right, for the last couple of minutes here, we're going to do something else that's a little strange. We're going to define another class here. We're going to say class bar. We're going to have bar is going to have bananas, and this is going to equal 15, let's say equals 6 to start. We'll have another def here, def init self x, and this is going to be self dot this other one equals x. I'm also actually going to, inside of class foo, I'm going to say def do stuff on self, print self dot this one. And here I'm going to say def do stuff self print self dot this other one. So class foo has bananas with a value of 3. Class bar has bananas with a value of 6. The def function, the construction function for bar sets this other one as the member variable as to say this one. So we have 2 different member variables. If I say A equals foo, like so, and I say B equals bar, I need to give them values. Let's say give them 10 and 15 as an example. Let's actually not give them numbers, let's give them strings. From foo, makes a little more sense. From foo, this is from bar, like so. Let's run that. If I say a dot do stuff, what do we expect to be printed? From foo. Because the a object is a foo object and it's printing the from foo, which is the foo part here. If I print b.doStuff, if I say b.doStuff, I expect what to happen? From bar. When I say b.doStuff, what I'm saying, or when I'm saying a.doStuff, either one of those, I look inside of a. Does a have a function do stuff? No. So what do? I look inside of the parent, and the parent happens to be the class. Does the class have a function do stuff? It does. Python automatically takes the left-hand thing of the dot and passes it as the first argument into do stuff. So do stuff has that argument here, self. So when I say a.doStuff, that self becomes that argument. That a becomes that self argument. I can also call do stuff like so. I could say foo.doStuff. But if I call it like this, what's wrong?
It's a class.
Do stuff is missing the required argument self. Because foo is not an object of type foo. It is a class. But I can pass a to foo. Or do stuff here. We'll print that from foo. Because a is that correct object type. So there's the a.foo.doStuff. What if I say foo.doStuff on b? You say it's going to print an error? How many people agree it's going to print an error?
Foo.
So we say a different class, right? So that's in Java, since it's a different class, it'd be like, hey, that's an error, right? I like that argument. That is not correct. That is incorrect in this case. However, it will print an error, but it's not because for the reason you said. What were you going to say?
Bar doesn't have this one.
Correct. The bar objects, B, does not have a this one member variable. So when foo.doStuff tries to print the this one member variable, the B object doesn't have it, so it will fail. Bar object has no attribute, this one. That's the error right there. If I said b.this one equals some other stuff, and I say foo.doStuff b, what's going to happen now? It's going to print some other stuff. Because that object b does now have the member variable, this one. Or the attribute, in this case, they call it attributes, member variable. On Tuesday, I was trying to talk about, is there something fundamental about keeping us from calling functions from one class on functions from, or on objects from another class? The answer is no. There's no fundamental reason why we can't. The reason why most languages like Java and C++ and C Sharp, C, Objective-C, and almost every other language with the exception of Lua and Python and a couple of other ones, don't allow you to do this is because bars don't have this ones, and bars don't, or the do stuff thing in food doesn't know what bars have. It doesn't know if it has it yet or not. If you're going to allow people to do this kind of behavior, this kind of function call, who's responsible for making sure the classes are correct?
We are.
The programmer, right? Are programmers good at remembering everything they have to do? No, we suck at this shit, right? It's not saying that I'm not saying that we're bad at programming, but we're bad at programming, right? That's just the way life is. It doesn't matter. It doesn't matter how long you do this, you're going to screw up when you start to use functions. Python gives you the ability to do that. If you choose to do this, whose responsibility is it to make sure you don't screw up? Ours, right? So just because you have the power to do it doesn't mean that you should do it. Right? This is something that you can do, it doesn't mean that you should do it. Let's make another function. The last thing we're going to do here real quick at the last minute is we're going to define print bananas. And we're going to take self, and we're going to print self.bananas on both of them. They're going to have the same exact function on both. I'm going to run that. If I say bar.print bananas on A. So bar, this print bananas function here, is being called on foo's object. Am I going to print the 3 or the 6? How many people think 3? How many people think 6? How many people go, I don't know, one of the two. So why do you think 3? 3 looks like a reasonable answer to me. Both answers seem reasonable to me, but 3 seems a little bit more reasonable. Why does 3 seem reasonable? Because the self variable here becomes that argument A, correct? What is the type of self now? Or what is that value? A. A is a foo object. So when I say A.bananas, does A have a bananas in it?
No.
No, A does not. But foo does. So if A doesn't, we look inside of A's class, which would be the 3. Right? What if I now change this to be foo.bananas and bar.bananas? Same thing. What is going to print? 3 or 6? Why is it going to print 6? Bar bananas, regardless of who self is. It doesn't matter. This is what I tried to do on Tuesday and failed horribly at.
So much better.
Right? Does this make more sense than what we talked about on Tuesday?
Yes.
Right? Hopefully it does. All of the language do this. Yes?
The first argument of the initial location, so no matter what you name that, that's always going to be
Correct.
That is because it's inside the bar, the object bar, right?
This one here?
Yeah. No, all those 3 functions are gonna be inside the object. All those 3 functions are gonna be inside the object,
Each one either inside the class.
inside the class.
Inside
Yeah.
the class.
So that's because it prints the 6 in this case.
Right. Because bar is bananas. If you didn't get your test, please come up and get your test.